Welcome again, licensed electrician, aspiring electrician from all over Jamaica, all schools and colleges, right, inner city, the diaspora, Africa. So today we are stepping up a notch. So we are going to talking about now motor control and information, right? And this African work. We don't have a lot of electricians who you have to master motor controls and automation, right? Process control, program with PLC and so forth. So that's why I said bright electricians, a lot of electricians study, get start from school early, get the grasp of it, because this probably less than 5% of electricians in Jamaica, all over Jamaica, can't know, don't know anything about motor control. A lot of them don't want to do it because it's challenging, and you have to bright, you have to study, right? So this is that aspect of the work. If you master this, anybody master this, can go just about as far as they want to go. So as I said, we're talking about industrial motor control automation. So here we are, right? I have a schematic representation of it. This is a line diagram, ladder diagram, right? And this is the wiring aspect of it with the different with the controls, right, and so forth. So we're going to go through step by step. So we're starting off as industrial motor control automation, and this is a simple ladder diagram here, line diagram, right? A ladder diagram is read from left to right and from top to bottom. And in this ladder diagram, we have two stop switches here and two start switches, the auxiliary contact, right? This is the coil, right? These are the overloads. So this is representing a three-phase motor, right, with three overloads, overloaded each line of the motor there. So we have two circuits here. We have a two-wire control, which is a single phase is going to be just controlled by a pressure switch, right? And we also have the three-wire control, which is this, the three-phase, the three-wire control, and this is the two-wire control. So we have, right? So as I said, now, electrician going forward now, electricians, remember now, important that you're able to read the diagram, electrical diagrams, right? Because if you have to interpret electrical diagrams, know what the symbols, the meaning of the symbols, right, and so forth, right? The color wiring and things like that, and supposed to know how to read the diagram and set up the circuit, wire the circuit. It all depends. You can create something on your own, or you can already been created, right? You see how it is connected, right? So here we're going now. The electrical diagrams that electricians are supposed to familiar with is the ladder diagram, the schematic line diagram, one line diagram, the wiring diagram, and the block diagram. So know the meaning of these diagrams, right? We have these diagrams and how to interpret them, and do your troubleshooting and also for your wiring and so forth, right? At the same time, now it is important where the National Electrical Code is concerned. And the JS360 National Electrical Code, right? Because whatever you're doing as electrical work, you're supposed to follow the code. You're supposed to go by the code, the standard, right? As it's there. And in this JS360, the JS360 National Electrical Code, there's an article, right? And that come out of chapter 4, and the article 430 in National Electrical Code that deals with motor control and so forth, right? The type of the safety devices supposed to put in place, the overload devices and so on, right? The wiring, I know you should size the wiring and things like that. So consult the National Electrical Code, Article 430, where they are going to deal with motor control, right? So we have it there, National Electrical Code there, up there, and the JS316, here, right? The JS316, and it's really directed to Article 430, where they are going to do anything with motor, right? So remember now, this is now our reference circuit that I have here now, right? And in this case, normally, the motor circuit is supposed to have the overload and the ground fault protection, which will be provided by the breakers, right? And now where the overload is concerned, we normally have the overload now, the part of the starter. Right, the starter and that overload is there to protect the motor from excessive overload. If the overload is the higher it is, that motor will trip cause motor trip inside there, protect the motor from burning up, right? But if there's a small overload, the motor will continue run as long as it doesn't pass the threshold set at, right? So as I said, this is now it just a simple setup I've done here. Demonstration to let show all the young electricians, aspiring electricians, all those electricians who want to be technicians and electrical engineers, right? So this is for you, right? So whether you're just going to college, you just leave college and you want to get a hands-on on the motor control, industrial motor control and automation, this is it. So remember now, so the basic thing now is start off, we potted there. I put up a 220, this is a single phase. I don't have a 3-phase here. So a single phase 220 supply I have here. But I have a 3-phase motor here. But I'm going to let the 3-phase motor running here. I don't have a 3-phase supply. So this is my panel distribution board. Make sure my panel distribution board is properly routed and bonded. That is important. Your wires are properly sized to your motor. So now you have to take into consideration the starting current and the running current where the motor is concerned. So that's why they consult the Article 430, I will tell you now. So I believe it is 125% conductor for the motor to get right. So 125% of the running current, right, are 1.25. Right, you size the wire accordingly. So when the motor starting, it have that the wire have some tolerance that it don't overheat, right? But when the motor start, as soon as it start to run, it goes down, right? The current drop, right? So as I say, so here are now my circuit here, demonstration of distribution panel. Ensure that my panel distribution board is properly routed and bonded, as I say, right? And these are now my we have 2 sets of devices. We have the input device, which is the pilot device, which is now would be the switches, right? And the and this is a pressure switch for a water tank. This is a limit switch, right? A photocell could also be an input device, right? And a float switch, right? A flow switch, a flow switch, pressure switch, a thermostat. All those devices we consider them as input device, right, or pilot device. And then you have the output now device would be the contactor, right, when it is energized, right, the car is energized and send the power, transfer the power to the motor. So and here we have now, let's show now, this is a contactor, simple contactor, right. It just right, this is a single phase contactor, just to start the single phase motor. And this is a starter. And remember now, it's the difference between the starter and the contactor. The starter, this is as an overload, right? This contactor, it doesn't carry a overload, right? But however, the starter carries an overload. So what we have gone through and done now is wire up a simple circuit, and right, I have a single phase motor there. This is my single phase motor, with a water pump here, and this is my 3-phase motor, right? But I do not have a 3-phase supply here. However, so what I have done to get the third leg, to get the motor running, I incorporate a capacitor in the circuit, and the capacitor will allow the motor now provide a third phase, allow the motor to start, right? Because the motor would start with a 3-phase motor would start on a single phase condition, right? However, when I just incorporate the capacitor in order to get it started, right? This now, the single phase motor is not a self-starting motor. This is a self-starting motor. This is not a self-starting motor. However, this motor is able to start, the single phase motor able to start because of the capacitor, right, apart to split the phase, right? So we're just going to go through now and see now if you are in line here now and things going. So just go through and check my voltage here. First thing now, make sure you have a good multimeter, right? Check your voltage, check for voltage, right? A multimeter can also use for tracing purposes, for continuity. And, so why now I ensure that I'm getting appropriate, they were getting 220 volts. It's a 220 volt circuit. That's a single volt 220. All right. My sub breaker here, 230 again. Right. So a 2 sub breaker, I have a 230 here, right? So 1 main 2 sub, 220 amp. So 120 amp. Each device, remember, each device is supposed to have its own breaker and own isolator. I don't incorporate isolator in the circuit today. Right, but he's divided, right? So I'm now just going to now start off now with my single phase motor here, right? And this is going to be my input, my pilot device, my limit switch, right? Because I want this is also would be an input device, but it is this pressure switch, but it's not connected to the pump right now, so it couldn't operate the motor. So I just incorporate this to get it going. So I'm going to start. I see my single phase motor start. So here my single phase motor running. Okay. All right. All right. So this currently this switch, this limit switch is connected. It's connected at the two open contacts, right? So when I move this the lever here, it closes the circuit, right? It can also, because you can also use the two normally closed contact, and in that case now if it is in a unpolished, it will open the circuit. So here my single phase motor now. Let me start my motor there. All right. So when it starts, it sends signal to the contactor here, right? Energize the coil, the relay, all right. The contactor close and send power to the motor and start to run. Now I'm going to go to my 3-phase motor, which is now this was a two wire control, and this is now my 3-wire control, which is now my 3-phase supply. So right, and I set up this the motor can be start. This motor can be start and stop from two positions, right? So there's a stop and a start switch here, which is this would normally be the contactor, right? I just take out the contactor or the case here. So you have this, you have the start button and stop button, right? Here we go now. Go to start. Here's my motor running now, and this is a 3-phase motor running, all right? 3-phase motor running. All right, I'm going to stop it. So stop my motor here. Stop it. All right. All right. So I can go here now. I can start it here. Start it here. And can go here. And stop it. All right. All right. I can start it here. All right. I can go here. And stop the motor, right? So I have that flexibility. Right? Yeah, I could even set it up like I can control and start it from 3 or 4 or 5 position, right? It's a very a big factory. This would be how flexible it is. Yeah, they just can incorporate a number of start and stop button in the circuit for convenience. So go ahead now again. Alright, start my motor. Start my motor here. Come here. Stop it. Right, stop it, right? I remember now, and here now is the overload now. So this overload in the circuit now will protect the motor. So if the motor jam, right, it's on an overload, right? It's jam or bearings from mechanical pressure, you name it, and so forth. The overload here will sense based on the setting, will sense the current, because the motor would build up heat that is more than what it's supposed to have. And it will sense it, and they just open. It will open the control circuit, and the coil will drop out and stop the motor, right? So come back here now. Just go over, just to show young engineers and bright electricians taking this. So I'm going to just go through now how the circuit operate, 3-wire control operate, right? So remember now, all the stop button are connected, right? The stop button are connected in series, and the button. And they are normally closed. So you see it? They are normally closed. They are all closed, right? The start button are connected across. They are connected in parallel, and they are normally open. So here it is open. There are 2 start button. It open there. It open. However, the stop button is closed, right? So they are normally closed. The start button normally open, right? So when I press the start button. Press the start button, right? What it does, it sends power to the coil here. The coil in turn now, right, cause the latching relay, which is this auxiliary contact to close. So when it close, and then right, it close it, it send now, you have to send power now right across, close the control circuit, and power goes through from the coil to the energize the coil, and then the coil cause the contactor to operate, right? So however, if you just go back now, whoop, right, open and press this, the circuit is going to open, and then this auxiliary contact is going to open, and then the power, you have to remove the power from the coil, and the motor will stop, right, providing the overload relay all these overload contacts are in, they would the circuit operate. So here it is, start button. So I have two start button, two stop button, right? It could be three, and it could be also four, but for now we're just using two, right? And the coil in this case, the coil is a 220 volts coil, so you have it now, line and line, 220 volts going to energize the coil. So the coil is energized from 220 volts. This coil is a 220 volts coil, right? In some cases, if it's a 40 or 20 or 24 volts coil, you'd have to use a transformer to step it down to just for the coil, right? However, the control power, the power here, the power going to the motor is 220 volts, right? So again, watch it. Here, start button, remember now, start buttons, stop button are in series and normally close, start button, right, parallel, and they're normally open. And this is the coil. So the coil is what actually cause the control circuit to close and operate and operate the power circuit, right? And here is the overload the particle motor from burning up. So the other thing with the 3-wire control, in case power goes or power should return, right? The motor wouldn't start, right? You'd have to, because this would normally would drop out. This auxiliary contact will open. The only way to let this auxiliary contact close is to press the start button again to let it. So that's one of the safety feature of it, right? So in case the operator is running the machine and so forth, power goes, and the power comes back, should come back, and the motor wouldn't start unless you start the motor. However, with the two-wire control, that's not the case, because the two-wire control is normally made now with this for motors which are unattended, right? Like water system and so forth, and certain process control. You have some motor they operate based on timing and so forth, right? So they pose any restraint to any operator, right? So here we have it again. So with 2-wire control for a motor, and with three-wire control, right? The schematic diagram from it, right? So we can go back over. So remember now your diagram, the different diagrams, read them. Your electrical diagram, your ladder diagram is diagram, your wiring diagram, your block diagram, and you use you have a multimeter. So if you're troubleshooting now, you can work forward and use a multimeter and trace the circuit, and while you're wiring to determine any fault and so forth, with the correction. So if we just wrap up, we're just going back again now, and here is just a motor. So these are two AC motor, and this is just a representation. So this is really what happened when the motor running, right? The coil there, energize, when the coil energize, the rotor inside it now, it induces a electromotive force, what they did it, and it causes it to rotate, right? And over the rotor speed and the stator field speed is never normally in sync, right? Yeah, when the motor starts running, there's a slip, right? And it start from about 1.5 to 5%. So you have to have that slip, because if you don't have a slip, no torque wouldn't be able to generate, right? And the motor normally supposed to provide torque to cause things to work, right? So simple motor, 3-phase induction motor, self-start motor, 3-phase motor, 3 windings, whether you call it in star or delta, and the simple single-phase motor. A single-phase motor normally have a starting winding and a running winding. It also some of our centrifugal switch, right? When the starting winding kicking start the motor, the centrifugal switch take out the starting winding and allow the running winding to continue to run, right? So go back now, right? For it now, motor controls, right? And remember now, this now can also, right? We have a relay here. So we have a relay here, contactor, and starter, right? So all these things can be incorporated in your control circuit, depends on what you're doing, right? So remember now, going forward, right, study motor control, right, so now be automated now, fully now, which we could incorporate the PLC system in it, which is the programmable logic control, and in that case, we could even stay home on the phone, right, and thing like the tablet, and operate your motor, your machinery, right, anywhere you want. As long as the card could be incorporated through the PLC, so you could write the program for it. Right, so that's why I tell you now, it's important now, electrician know these things, get it over because, who know this and can master it. I was not, but, they were here, but they would be above most electricians because most electricians are not going to get this, are not going to do it, right? They're running from it because first thing you have to have the book, read, practice it, right? And if you don't love it, you don't get it, right? So what it is now, one more test now with my motor here now. Let's see what's going on now. Right, start my single phase motor there. Single phase motor running. Contactor close. Come up close and now you can see the contactor there. The contactor now running. Single phase close circuit. Contactor jump in. Start motor. Open. Motor stop. Alright. Now we're going to start now my 3-phase motor. I have this motor now can be started from 2 position and also stop from 2 position. This is one started from this position. There's my motor running there. The coil close. Run my motor start. Come here, I can open it, stop it here. Alright, stop it from this, so I can go here now. Start it here. Alright, can go over here and stop it. Alright. So anywhere you can start back, stop it here. So I could this could learn from 3 to 4 different positions, and here's the representation of it. 2-wire control, 3-wire control. This is the simple, right? Ladder diagram. Ladder diagram read from left to right, top to bottom, right? And normally when you're reading a diagram, it represents that the circuit is at rest. Right, in this sense that there's no power connected to it, right? So here it is, start button, normally connected in parallel, normally open, connected in parallel. Stop button in series, normally close. This is my coil, right? So start the motor, come here, start the motor, boom, energize the coil, auxiliary contact. Close, hold the circuit. Circuit is hold, right? And power go right through, right? And feed the power circuit, right? So when they press this stop button now, right? The auxiliary contact is open and drop out the auxiliary contact, and there's no power going to it. So here, 2-wire control, 3-wire control, input device, the pilot device, output device. Yeah, right. So electricians, go on now the page. jmelectricians.com, right? Just type in definition for electricians or mock exam for electricians. Jamaica, there's a lot of definition exam and a lot of other useful information because now, I said now, all electrician youngsters who want to go say they're going into engineering, whether it's electrical, mechanical, because this can do for mechanical, industrial, right, engineers, not just electrical engineers, right? You can now start, this is a head start for you, right, and eventually when you're doing your lab and so forth, any hands-on thing now, this now come in handy for you. And electricians out there now who want to upgrade themselves, right, you can also get on board. So those who have a passion and love it, right, and know that, right, and love a challenge, is for them, it's not for person who can't bother, right? So get your book now, as I said now. So there's some book over there, some book, wire diagram book, this ugly reference manual here, and a lot of things in there, diagram, wire diagram, and so forth, right? Electrical code, right? Electrical theory and practice, very important. Get the fundamentals. This is one of the best textbook for electrician 12, right? So until next time, continue to watch, follow, and right. And remember now, look what just show them how to set up again now, youngster now we're getting we have a 3-phase motor, right? However, I don't have a 3-phase supply here. I have a single phase, but I still get the motor going by incorporating, right, this capacitor, right, to provide a third leg and get my motor to run. So here my motor running there, right? This is a 3-phase, however, it is getting a single phase with the aid of the capacitor to get it running. Alright? So I start my motor. Alright, so that's it for today. Until next time, continue to follow, watch and subscribe.